Good afternoon and good morning. Welcome back to management accounting. We are now going to look at the discounted cash flow techniques. First, we're going to start with net present value, otherwise called NPV. The most widely used this version of the DCF, disc, discounted cash flow, is the and DCF mean what? Discounted cash flow, right? It's the net present value method. The NPV method computes the present value of all cash flows using an interest rate called the required rate of return. This rate, also called the hurdle rate or discount rate, depends on the risk of a proposed project. That is, the higher the risk, the higher the rate. It is often based on the cost of capital, which is what the firm pays to acquire more capital. So go again. The NPV method computes the present value of all cash flows using an interest rate called the what? Required rate of return. This rate is also called the what? Hurdle rate or discount rate. It depends on the risk of a proposed project. That is, the higher the risk, the higher the what? Rate. Or we should say, depending on the risk of a proposed project. The higher the risk, the higher the rate. It is often based on the cost of capital, which is what the firm pays to acquire more what? Capital. So the rate itself is what? Based on the what? Cost of capital. Using the required using the required rate, managers sum the present values, add them up, the present values of all expected cash flows associated with the project and subtract the initial investment. Alright? This total is the project's net present value. A positive net present value means that the present value of the project's future cash flows exceeds the investment. So the project should be what? Undertaking. Go again. A positive net present value means that the present value of the project's future cash flows exceeds the investment. So the project should be what? Undertaking. Conversely, a negative NPV means what? Investment exceeds the what? Present value of the future cash flows. So the project should not be undertaken. These are this phrase, this part here, very important to remember. Alright? Good. We're going to apply the NPV method now. To illustrate how DCF models work, we will use the following example throughout the rest of the section. Managers at Texas Tupelo, Mississippi plant are contemplating the purchase of new, more efficient outdoor painting equipment that they expect will increase efficiency and produce operating savings. The cash flows associated with this investment consist of the following: initial investment cash outflow of what? 5,827 at time zero for the acquisition cost. Annual cash savings equivalent to a cash flow of $2,000 at the end of each year for the 4-year life of equipment. No net cash flow at the termination of the project. The required rate of return is what? 10% per year. Otherwise called what? Required rate of return, and so forth. To apply the NPV method, you can use the following 3 steps. Identify the amount and timing of relevant expected cash flows and outflows. The right hand side of the table below sketches these cash flows with outflows shown in the what? Brackets. So first thing you do is identify the amount and timing of relevant expected cash inflows and outflows. Right? Alright, let's look at the table now. So the right hand side of the table below sketches these cash flows with outflows shown in the brackets, right? So look at this now. outflow. Year 1, year 2, year 3, year 4. And this one now, and so these are the cash savings in 2000, 2000, 2000, 2000. Alright, so complete that. So after you would, so the right hand side of the table below sketches these cash flows with outflows shown in the brackets. And the outflow is how much? 5,227, right? So the the um the 2000 are the what? Annual cash savings, otherwise called cash inflow, and the outflow now. Outflow is the amount. The outflow is in the brackets, which is right here, which is the amount that was invested. All right, let's continue. Then you find the present value. Should be present value. Sorry, of each expected cash inflow or outflow using the present value of um, $1 table. Find the present value factor of each year's cash flow from the correct row and column of the table. Multiply each expected cash flow or outflow by the appropriate present value factor. For example, the present value of $2,000 cash savings that occurred 2 years hence is, hold on. Now to get this 0.8264 here, what you should do, wondering how did they get this 0.8264. Now what do you do? When you're doing our finding present value, we usually call financial tables. Now, so to get the 0. Alright, first thing, to get the 0.8264 right here, you'd have to go to your financial table. This is an example of one. I upload it to you. Then you look for the percentage, which is the interest or required rate of return or required rate of return or interest rate or whatever that is given. You look for the rate, which is 10%, and look for the year, which is 2 years in this case, would have been 0.826. The 4 is off because the fact that 864, you roll it off, you get 0.826. Alright? Some tables would have given you 0.8264. Let me give you a little more so you can see what I'm talking about. Here for 10% and look for 2 years, line them up, 0.826. So that's how you really get it, alright? So you'd have to look on the financial table to get, so that's where you get the 0.286, the 0.8264 from. Then multiply the cash savings by the 0.8264, and that will give you your net, that will give you your present value for the current, for that period. Alright? Now, after you have found all of those, you then what? Sum the individual present values, as in you add up all of them, add up for year 1, year 2, year 3, year 4 in this case. You add up all of them, the sum is the project's NPV. Accept a project whose NPV is positive and reject a project whose NPV is negative. Alright? The present value of the initial investment is 5,827. The present value of the 4 annual cash flows is 6,340. and there are no cash flows at termination. Thus, the net present value of all cash flows is 6,240 minus 5,827, which would be equal to 5,113. Because the net present value is positive, the manager should accept the what? Investment. Let's look at it now in more detail. So, first things first, this is one way of doing it. You have the discount the cash flow for each year separately. You have year zero, year one, year zero is the initial outflow, which is 5,827, right? Then for your present value of $1 discounted at 10% now would be a case where you go now and you're gonna find the percentage and the period. So you'd go to your present value table, 10%, 1.1909. They would multiply that 0.909 by 2000, you get what? 1818. You do the same thing for period 2, 3, and 4. And when you would have done that, you multiply all of them, and then when you finish all of that, you add up all of these present values that you would have gotten, and that will give you the present value of the future inflows. Sorry, the present value of the future inflows is 6,340, and then now you're gonna add the 6,340 to the 5,827. When you sum up all of that now, you get 513. Technically, you're subtracting the initial outlay from the present values, right? But if you check it out, remember when you said that a while ago that the sum is what projects NPV. Now this is the reason why, because by right, what you could have had, however, you could have had that you would have had this at the top being negative, add up everything to it, you get what? The 513. Now since 513 is positive, that means what? The project should be accepted. Alright? When the NPV is negative, the project should be what? Rejected. That is very clear as crystal. Alright. The effect of required rate now. Now a decrease in the required rate of return can change the NPV from negative to positive. In general, the higher the required rate of return, the lower the present value of each future cash flow. Of each future cash inflow, right? Go again. In general, the higher the rate of return, the lower the present value of each future cash flow. Remember, the required rate of return is the percentage that you are normally given, right? Otherwise called a hurdle rate or the what? Discount rate, right? And it is often based on the what? Cost of capital, which is what the firm pays to acquire more capital. So the term cost of capital is the firm pays to what? Acquire more capital. So if you see in a question the discount rate and the cost of capital, you know that you should use the discount rate to do your calculation for the NPV, right? Not the cost of capital though. Don't use that. Use the what? Discount rate or required rate of return. Okay. All right. So you have okay. I've paused the video and written this down. Thank folks. Pause the video. Write this down. Write this down. Thank you. All right. So in general, the higher the required rate of return, the lower the NPV. Sorry, the lower the present value of each future cash inflow. Why? Because the higher the rate of return, the more it costs you to wait for the cash rather than having it available today. Alright? Thus, higher required rates to lower NPVs. Alright? For example, the rate of 60%, the NPV of the project would be negative 231. This is 2000 times 2.7982 equal 5596, which is $231 less than the investment of 5,827. Instead of the positive 513, compute with a 10% rate. When the required rate of return is 16% rather than 10%, the project should be what? Rejected. So the higher, if the rate of return is higher, goes higher, then you have a negative NPV most time, right? And that would be a problem. If that is the case, say reject. So there's always there's something that we always tell people. So I must let you know that if the NPV is zero, then the project should be accepted. But once it is less than, once it goes negative, it should not be accepted, right? Alright, let's go now to the IRR, the next discounted cash flow technique. A popular DCF model is the internal rate of return, otherwise called IRR model. This model determines the interest rate at which the NPV equals zero. The rate that makes the NPV equal zero is called the IRR. For Toyota's painting equipment, we know that a rate of 10% yields a positive NPV, while a rate of what? 16% yields a what? Negative NPV. As discussed in the effect of required return section. Therefore, we know that the IRR, the rate that yields as net NPV equals zero, is somewhere between 10% and what? 16%. The IRR for our example can be found by trying values. So IRR is done by trial and error, I must let you know, between 10% and 16%. Converging of the return that yields a present value of zero. Most spreadsheets and many financial calculators include functions that solve for the IRR. The IRR for painting equipment example is 14%. To confirm that this is the IRR, compute the NPV at the rate of 14%. Outflow in today's dollars 5827. Inflows equivalent in today's dollars is at 40% will be 5827. And they are because 2000 times 2.9137 from the present value of ordinary annuity table. What they did was 14% for 4 years. Let's go to it because right through the $2,000 would have been used, right? For the 4 years. Let's look at it now. Present value of annuity table. Sorry, not that one. So this is what? So 14% for 4 years. Look at 4 years first. 4 years right there. Go across. Shoot. 4 years. Go across. You have point. Yeah, wrong place. Sorry. So present value of annuity for annuity under annuity. Go across 4 years. 3.0 was the last one. 4 years. 14%. And you put at 2.914, and then you would what? Multiply that figure by 2000, you get 5,827. That would be 14%, right? In most cases, the IRR method gives equivalent decisions to the NPV method. But this can be done, watch this carefully. This can be done. You can use the present value of ordinary annuity if you have a fixed amount of investment. But there are times, as in fixed amount of cash inflow, right? But there are times whenever it can be different amounts going in, right? In most cases now, the IRR method gives the equivalent decisions to the NPV method. In general, we find the following. If The IRR is greater than the required rate of return, then NPV is greater than what? 0. I should accept the project. If IRR is less than the required rate of return, then NPV less than 0, and we should reject the project. Because of the equivalence of NPV and IRR models, most of NPV and IRR models for most investment proposals. Before we go any further, I have something to share with you regarding NPV and IRR. Here now is another example of NPV, right? As said before, the net present value is what remains after discounting all cash flows by the required rate of return. Please write this on this formula, this formula. K equal what? In this case, equal the required rate of return. Now, if the sum of the discounted cash flows is 0 or more, the project should be what? Accepted, if not rejected. Assume now that the following cash flows and the required rate of return of 12%. Now this negative 18,000 is the what? Cash what? Inflow, right? Cash outflow, I mean. And then you have a fixed amount of 15,000, 5,700. Now this form that you see right down here, so you have so what we have in here is that you have for the for the formula here is really, this is the present value formula. Good. For those of you who don't know or remember, this figure up here represents what? Cash flow 1 plus R, or 1 plus I, or 1 plus K. Okay, good. Now this formula is representative of this formula right here. Good. So you have the cash flow 1 plus K time. Time is the period. So the first one will have been 1, then you have 2, 3, you have 4, right? Good. This is the formula for that part. Good. This is an NPV formula really. But this section now, I will show you a while ago. That section we're looking at right now, this one. So it's cash flow 1 plus R. And R is 12%, so it would be 12 divided by 1 will give you a 0.12. This is the first part is 1 year, 1 period, right? Then you have 5,000 plus 0.12. Now, there's the second part. Now, in you could have used the table. Instead of doing it, you could have used the table and multiplied. If you're using the table now, you'd have multiplied that figure by what? 5,700 in this case, right? And we could have also, instead of going, because we have an annuity, we could have used the table, find 12% and find what? 5 years. Are we good to go, right? When you would have done all of this now, I'd have added them up. So what you could have done, go again. You would find 12%, then go to 5 years, right? Annuity. 12%, 5 years. What's that? 3.605. Now if you multiply, let's do it with me, please. You will multiply 3.605 now. Sorry. Multiply 3.605 now by 5,700 and see what you get. So you have 5,700 multiplied by 3.605 and get what? 20,548. This is when you have a annuity. You could have done it like that using a present value annuity table. And then add the two of them together now. You sum everything. That's why when I was going to the video before, I said when you sum the NPVs, and the NPV include what? The initial outflow, initial outlay, which is 18,000. And together you get 2,508 positive. Now if the required rate of return is in line with the rate investors expect the firm to earn on the investment project, and the firm accepts a proposal with an NPV greater than zero. The market price of the stock should rise since the firm is taking on a project with a return greater than necessary to leave the stock price unchanged. Now we're going to look at something called IRR now. Now, the IRR of an investment proposal is a discount rate that equates the present value of the expected cash outflows with the present value of the what? Expected cash inflows. This is a formula method to do that job, but the point is we don't have a IRR. We need it. So the try. So the IRR is found by what? Trial and error when done manually. Look at it now. Now remember that our we are using the same question. Remember that our required rate of return is what? 12%. Good? Note it. Alright. And alright. Now this question says we're gonna try 15%, 16%, and then see what happens. Good? Let's go. And why would you do that, by the way? Remember that IRR is supposed to be equal to what? 18,000. The IRR is supposed to be equal to the um. So, so the IRR is the look again. Let's go again. The IRR for an investment proposal is a discount rate that equates the present value of the expected cash outflows. So that means if you use the IRR percentage to calculate your present value, you will end up with back with at 18,000. So the IRR is what you are trying to find that percentage that equates instead of having 20,000 something, you end up back with what 18,000. That's what IRR is really about. Good. So we're gonna try 15% and 18% in this case. Ready? And we are saying now that it will lie between 15% and what 18%. Good. Let's go. Now try. So what you do here now, you'll find 15% on your present value is sort of table, not the annuity one now, and you get 0.870. I'm going to do the first one for you. So you you don't use this one with annuity, use the regular one. Present value interest factor table, not the one with annuity. Okay? Please note that. And you go to 15%, 1 year, 0.870, right? And so they got the 0.870 right here. And they multiply these two, and you get this. Good. You do it for all of them, and you have another all the discounted cash flows. You get 90,112.1. This represents the 15%, right? Then you do the same for 18%. Multiply the 0.87 by 5 you get 4,000 other and so forth. Add them up. This one represents what? 18%. Now notice now the 18%. With 18% you end up with less than the 18,000, right? Good. All right. Now with 50% get above. Good. So now we're going to say no IRR. You're going to put the IRR now over the difference now between the two to find where the IRR fall between 50% and 80%. Determine the proportion of the difference, right? So we have IRR over 0.03 equal. Now this 112.10 is minus the 18,000 from the what? 9,112, and to get the 1,288, you will have to minus, check something. To get this figure now, you minus the 17,800 from the what? 19,112.10. Then you would say, alright, you're going to cross multiply now. Sorry, not cross multiply. You're going to get rid of this 0.03 by multiplying this by both sides. So you end up with IRR equals 0.03 times 112.10 times, times that divided by 12288.2, which equal to 0.25899. And because we're doing percentage, you can multiply this now by 100, and you're going to add this. So therefore the IRR equal to 15% plus 2.5899%, which equal to 17.59%. So this now would be your what? IRR. It's not so difficult to understand. You have to go back to the video, pause again, and try to figure out what I'm doing. Alright. First, the main thing is to get these figures out of the way. Then equal them with their percentage, right? Remember that IRR should be equal, should bring you back to the original cash outflow. Alright? This is the tricky part where you would have put the IRR over the difference between the percentages, and then equal it now to the difference between the cash outflow at the top and the other one at the bottom. So you would minus this from this to get this, minus this from this to get this. Alright. Thank you very much for watching, and do have yourself a wonderful day or evening.